Okay, so this is 8.4 part 2, solving quadratic problems. So these are going to be word problems that involve quadratic equations. We're just going to do one together, and your homework, I'm just giving you 2 homework problems. Now, one of them is similar to this one of them is different. So I really want you guys to try the one that's different, even though we haven't done it. Try and do it. Okay, you guys can do it. Alright, so here is our situation. There's a girl and she's riding a motorcycle. And she rides the motorcycle 300 miles. Okay, so she rides it 300 miles. It's pretty far. That's farther than all the way across Missouri, where I'm from. Wow. Yeah. Well, that's a lot farther than 300 miles. So, if you go from, I think, like, well, I used to live in Kansas City. I think if you drive from Kansas City to here, it's like 800 miles. Okay, so she rode it 300 miles, and she's going at some average speed. We don't know what the average speed is.
How many miles is average? Oh, wait.
We don't know.
You know what? I'm sorry, guys.
It's okay. So we don't know how many miles per hour she goes.
How long did it get there?
I'm gonna tell you. I'll tell you that. And actually, I'm not even gonna tell you how long it took her to get there.
It's 3 hours.
Well, she's going an average. Like, she averages out. She averages out. But here, I'm not gonna tell you how long it took. I'm not gonna tell you how fast she went, but I will tell you, if she had gone 10 miles per hour faster, it's not that bad. If she had gone 10 miles per hour faster, her trip would have taken 1 hour less. So she would have gotten there an hour faster if she went 10 miles per hour faster. This is
10 miles an hour.
Hear me out. I've told you guys this before. So even though you might not do this exact problem or something even like it, this is working your brain out. It's sharpening your problem-solving skills. Because you're going to have problems in your life. All kinds of problems.
I don't care how out of money. I'm going to be like...
There you go. You're out of money. Guys. Hey, Fiore, can you stop talking? Hey, Clay, can you stop talking? Jamie? Exactly. Exactly. I don't know what problems you're gonna face. Exactly. 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 Yeah, exactly. No matter what your job is, no matter what you end up, even if you're homeless in Chicago with no money. Alright. So the one equation that you guys need to know to solve this, and we've used it before this year, you'll use it a lot in your science class next year, is that distance equals rate times time. Actually, I'm going to write that out in words, because we're going to make a chart anyway. So if we write it out, distance equals rate times time. I think I even made you memorize that last semester. Yeah, distance equals rate times time. Dirt. D-R-T. D equals R-T. Alright, so we could write 2 equations based on these situations that we know. We know what actually happened, right? What actually happened was, how far did she go? 300 miles. And do we know her rate? No. So we know it equals R times, do we know how long it took her? For her normal trip. T hours. Her normal trip was 300 miles. We don't know the rate and we don't know the time. That's okay. We can plug those in. Now, for her one where now let's imagine her going faster. If she had gone 10 miles per hour faster, it would have taken an hour less. So now let's make a new row for that situation. Did her distance change? No, she still went 300 miles. Did her rate change? Jamie? R plus 10. Who can tell me what her time would be? Lauren?
T minus 1.
Nice. T minus 1. So we're going to set up two equations here. We're going to set up two equations, and then we're going to use substitution. We did that kind of a long time ago to solve it. So we've got, let's kind of condense them down here. So here's equation 1, here's equation 2. So equation 1, I'll write it down here, is 300 equals RT. Right, that's it. Our second equation is a little more complicated. It is 300 equals the R plus 10 times her time minus 1 hour. So do you guys remember substitution where we solve for one variable and plug it in the other equation? So what we're going to do is let's get, which equation do you think would be easier to get a variable by itself in?
T minus 1.
The first one, right? So let's use our first equation, and let's get, it doesn't, you could do it either way. In mine, I got R by itself, so let's get R by itself. Do you guys know what R would equal here? Who can tell me what, if I got this R by itself, so I move the T away, what would R equal? Jeb? I don't think we want to subtract it. How do you want to get rid of this T? Nice. So it's going to be 300 divided by T. And let's write it with a fraction, not the little division symbol. So the first step of substitution is getting one variable by itself. We got R by itself in that equation. So do you know where we're going to plug the 300 over T in? For R in the other equation. So we're going to plug it in for R in that other equation. Yeah, this was, actually, you guys were first learning about substitution about this time last year, and we redid it this year. So I'm about to teach it to my 7th graders. All right, so let's rewrite this second equation, but we're going to plug that R in. So I've got 300 equals, instead of R plus 10, we're going to write the 300 over T plus 10. Is this how I did it? Yeah. Okay. Yeah, good. Plus 10, and then the T minus 1. What do you guys think I should do now to start solving this equation? Let's multiply. FOIL, right? So what is, this one's nice. What's 300 over T times T?
300.
Just 300, right? So this is 300. Let's see, 300 over T times negative 1. Yeah, good. Negative 300 over T. So we did the first, we did the outer, now we have the inner. 10 times T is 10T. And then last, 10 times negative 1 is minus 10. And we still have this 300 on the other side, too. Now, well, let's see. We could combine those like terms. But, you know what? I think we should do something else first. Let's subtract 300 from each side, because there's a 300 on this side and a 300 on this side. So those will just go away if we subtract them. Let's do that, because then it'd be less to work with. So we're going to subtract 300 from each side. So we've got, what's on this side now? 0. 0 equals, we'll just leave the rest of it over here. Negative 300 over T plus 10T minus 10. Now we could add the 10 over to the other side, but what I would think maybe we want to do is there a way we could not have this T in this denominator? Yeah, let's multiply everything times T. And which is kind of nice that we got this side to be 0, because what's T times 0? 0, so it doesn't even change that side. So now what's this first term going to be? Oh, hi. you want to do my printer? Oh yeah. Let's see. Yeah, we're gonna be done recording in like 5 minutes. 5-10 minutes. That was. That was. All right. So what's negative 300 over t times t? Negative 300. What's 10t times t? 10t squared. Good. And what's negative 10 times t? Negative 10t. Good. Oh, it is. What are those things called? Quadratic formula, quadratic equations, right? So Lauren said this is going to become one of those things that has like a t squared, a t, and a regular number. Let's rewrite this side in that order. So it's 0 equals 10t squared minus 10t minus 300. So there's a t squared and a t, so we're going to have to solve by either factoring, completing the square, or quadratic formula song. Is there something you could do to everything right now? Divide by what? 10. Let's divide everything by 10. That will make it a little nicer, right? Let's divide every single thing, both sides, by 10. So this is like the triple heart method over here. So let's see, what's 0 divided by 10? 0. All right, on this side, what's my first term going to be? T squared. This one? Minus t, right? Negative 10 over 10 is negative 1. And then this one? Minus 30. Good. So remember, when we're solving a quadratic equation like this, anytime you see a t squared and a t, or an x squared and an x, first you want to check for, can you factor? Second, I would check for completing the square, like would it be easy to complete the square? And then if neither of those work, you can always use the song, the quadratic formula, the all over 2a. Can we factor this one? Jamie? You could do that, but you know what? If you did that, you would change the first one to a negative, so I would leave it positive. But that is true. You change them both. Come on, you guys. Someone can factor this. Someone factor this for me. Jem? Charlie? You could, but if we're gonna factor it, we want it equal to 0. Connor? What sign is each one? Connor says negative 6 and positive 5. Do those multiply to negative 30? Do they add to negative 1? Yes. Negative 6 plus 5? Yeah. So we can do t minus 6 and t plus 5. Okay, man, I'm a little scared. That should have been like right away. No, we'd never forget how to factor. So now, what are my two solutions? What would make t minus 6 equal 0? What value of t? 6, right? 6 minus 6 is 0. What plus 5 would give me 0? Negative 5. 0 plus 5 would be 5. It wouldn't give me 0. Now, so this is what it tells us. The time it took her to make this 300-mile trip was either 6 hours or negative 5 hours.
6 hours.
Okay, yeah. Negative 5 hours doesn't even make any sense. So we know that it took her 6 hours to make the trip. Now, what we wanted to do was we wanted to find the average speed. So we need to go back and look. Yeah. So just remember that distance equals rate times time. Do we know the distance? 300 equals her rate times 6. So what do you do to get her rate? Yeah. What is it? 50. So her rate is 50 miles per hour. And we could plug that all back in, which we should do, and check it. I won't make this too bright. So, see, it's not too bad. It's kind of a long problem, but... All that was figuring out her speed. So you guys have page 530, number 23 and 33.